The third video in Module 3 where we were focusing on the empirical formula. So in the first video we saw the gotcha question that trapped the students. Now you could make a case that they just didn't understand the definition of empirical and molecular formula and they got it reversed, or they were confused. But it sensed that they were pretty close to figuring it out. So we went through the training pretty quick, so I would recommend watching video 2 several times so that you can be familiar with the whole training on empirical formula. But here we're going to go through some of the different questions that you're probably going to see. From the archive of exams, there are a lot of empirical formula questions that sort of have this look, where they give you the percentages of the carbon, hydrogen, and oxygen in this case. Let's say it's a combustion experiment. Now if you sum this up, it's probably going to be 100, right? 100%. It has to be. I mean, if this is basically all you have, then by definition, the sum of the parts should be 100%. And then we know that we just go through a roadmap of converting these to grams. We just assume 100 grams, and then we have 64.27 grams of carbon, and then you have 7.191 grams of hydrogen and 28.54 grams of oxygen. Convert those to moles because we know the relationship between moles and atoms, and then from there we can figure out the ratio, and we want the smallest whole number solution, and so we can use that to determine our answer. You would do the same question here, but it's a little different. It's the molecular formula of the compound. We know the molar mass of the compound is 132 grams, and we know that the empirical formula is C2H4O. So what we need to do is first, what is the mass of this empirical formula? And then when we do that, I mean, of course, we can quickly go, well, 2 carbons, that's going to be 24, and hydrogen, that's 4, and then oxygen, that's 16. So what are we at? We're at 24 plus 4. Yeah, at 28 plus 16. I mean, you are at 44. And so, I mean, that looks like a 3-to-1 relationship. So quickly you would say, it looks like B, right? Because that's a 3x of the empirical formula. So that's sort of how you would step through between the difference between empirical and the molecular formula. Let's make this a little bigger so you can see it. Another different format here. It's a combustion analysis. Again, you're burning a hydrocarbon, so it produces water and CO2, and you want to know what the empirical formula of this compound. Now this is this is another level because you're trying to figure it out. But here's the key. The amount of carbon is in this hydrocarbon will help you. So again, you have to figure out the grams of carbon here. You have 2.197 grams of CO2, so then you convert how many grams of carbon you would have, or how many moles of carbon you have in that, and then from there you can back calculate and get the ratio of this compound, which a hydrocarbon is basically carbon and hydrogen. So you really just need to focus on your hydrogen and the water and the carbon and the CO2. In this question, it's another combustion where you have a compound of CNH, that's a hydrocarbon, and it's combusted in oxygen, and it yields very similar. Now you got 2.955 grams of water and 7.217 grams of carbon dioxide. So you have to use that information to calculate the empirical formula. And let's look at this last one since we've looked at a lot of carbons and hydrogens. Here's one. What's the empirical formula for nitrogen oxide that contains 30.44% mass of nitrogen? So in this case, if you assume 100 grams, you have 30.44 grams of nitrogen, 69.36 grams of oxygen, and here's your roadmap. Convert this to moles, then find your ratio, and then find the smallest whole number if you get some fractions in the ratio. That's how you solve for the empirical formula. All right? So good luck. Watch this several times. I recommend really understanding combustion because I would expect you probably might see a combustion problem where you're looking at water and CO2 and you have to back calculate the empirical formula. So heads up, look out, and good luck on empirical formula. This is Brian Metzger. Thanks. Bye.